Okay, we're spot on 7 o'clock in the morning. My name is Chris West. I am a member of the Vermont Home Builders, a previous president, and a member of a number of committees, including the Education Committee. And today we have with us Steve Spatz, who works for Efficiency Vermont, which is a major sponsor of the Home Builders. And Steve has been spearheading the Efficiency Vermont education on the new 2020 residential building energy standard. And we're very happy and pleased that he was able to join us this morning to share the changes to this prescriptive compliance method. Steve also has a number of other videos which are on our website, which deal with more specific things on a number of different fronts. And yesterday, Steve gave the full 2.5 hour everything that is the 2020 RBES from soup to nuts. And I'm pretty sure that that will be available at some point. I don't know, Steve, I would assume you recorded that.
I believe that one was.
Okay.
I'd have to check with Bryn to make sure that that was happening. We have one more session of the full 2.5 hour code training I'm going to do on August 5th, I believe it is. So that'll be happening one more time.
Great. By the way,
and as many more as people will tolerate, I suppose, too.
Importantly, all of the scheduling for these things and other Vermont VEIC and Efficiency Vermont trainings are available on their website. There's a link on the education page of the Home Builders.
All right. Well, we'll give it a go here, Chris.
Yeah.
Okay, so thanks for everyone joining here this morning, and Chris and VBRA appreciate the collaboration on this and helping to get the message out about code. My role with Efficiency Vermont, I am both a residential energy consultant and an account manager.
I was thinking that in the middle of the night. Do it first thing in the morning.
If everyone could mute, that would be great. I don't know if you can find the mute spot on your screen.
You mute us. What? Mute us.
Give everyone just a second here.
Norm, if you could mute yourself, that would be great.
Yeah, we're working on it.
Okay, great. Thanks.
Right, thank you. So my role, I've worked as a project consultant in our residential new construction program, as well as a contractor partner manager with our existing homes contractors, Home Performance, and also have worked pretty closely with our building suppliers over the past few years and deepening relationships with them and as a technical resource. I now also am the primary contact and lead for our RNC, new construction, and architects members for our EEN network. I come into this role as a builder myself, was my previous life, and a partner contractor with Efficiency Vermont for quite a few years leading up to coming to work here. So I've put a lot of effort into code outreach over the past few years. I've utilized the relationships with the building suppliers as a primary way of making those connections, since so many of you involved in selling building materials are the kind of the primary contact for a lot of contractors as to where they are getting their information on building science and assemblies and code. So we're presenting this today as my role with Efficiency Vermont. Efficiency Vermont serves as the Energy Code Assistance Center for the state of Vermont. The code is administered and owned essentially by the Department of Public Service, but Efficiency Vermont's role is as the supporter of the implementation of code in the state by way of the Energy Code Assistance Center. So I feel this is our primary role in trying to share information. We have no role in enforcement whatsoever with the code, but we're here to serve as a resource. So today we're going to focus on prescriptive compliance for the 2020 RBES. The prescriptive path is one of the 3 options for compliance with the code. The reason I'm focusing on the prescriptive path today is because it's kind of the backbone that any of the compliance methods are built upon. So the main meat of the code is contained in the prescriptive compliance path. This training today is also focused on new construction. We do have a separate one that goes into more detail on existing homes. Kind of mention it, but the content today is really more focused on new construction. So just a quick background of the code itself. The RBES was created as a code for energy efficiency for the state as a part of Act 20 in 1997 by the Vermont State Legislature. Typically, it has a 3-year revision cycle for review and updates to keep current with both the IECC and other standards. It was a little delayed, obviously, this time around, and we are at the point where the code will become law, become in force as of September 1st. So any projects that start a shovel on the ground or begin as of September 1st or after, or are permitted on or after that date, are required to meet the provisions of the 2020 RBES versus 2015. So just a quick overview of some major changes for 2020, and then we'll get into more detail. New installation requirements and packages. The primary change here is that the prescriptive packages now have a points requirement too, where points need to be gained, as well as meeting the basic requirements of the prescriptive tables. Those points requirements vary by the size of the house. So the bigger the house, the more points are required. There's more options for ventilation, and we're talking mechanical ventilation here, not rafter vents. Blower door testing is required. That's a big change for 2020. Any code, things that are not necessarily going to be not universal for single-family homes, but we'll get into that a little bit further along. One distinction I wanted to call out early on here and clearly is that there is definitely the distinction between the actual code itself and the full rule of the law and the RBES Code Handbook. They're two different things, and one should not be supplanted for the other. And it looks like my jumping along the slides here a little bit. Many of us are familiar with the RBES Handbook. Been a variety of colors over the years. The code book, or the handbook, is published by the Department of Public Service. Efficiency Vermont contributes to the content for it. Handbook is still being ready to be published. It is not published yet. Hopefully that will be happening sometime soon. It's in the department's hands to take it forward with that. We don't know what color the new one's going to be this time around. There was discussion of kilts in the last conversation around it, so it could be plaid, we don't know. But there is a clear distinction between the handbook and the full code. The handbook is basically there to provide guidance how to apply the code in the field. And the full RBES code language itself, which is available through the ICC, contains all of the code requirements and the detail of the code. So I encourage everyone to become familiar with both, and the content of today's training is going to be linked directly to the sections and the code language of the full code itself, not to the guidebook. So something I just wanted to make sure that, that message, if it's not clear, is understood. As a builder myself, I was more connected with the code handbook than I was with the full code. So it's definitely something to be mindful of. These resources can be found at the Department's of Public Services website in the energy efficiency section. The 2020 full code language right now is not available through ICC yet. They're still working on the publishing of that. So if you go to the energy efficiency link at the department's website, you will find the update, energy code update, and you'll be able to see the full language of the code right now for 2020. It's in draft form, but the full code language is there. So that's your resource to find these documents moving along. So which buildings must comply? New construction, low-rise residential, so 1 and 2 family dwellings. Multifamily, that is 3 stories or less. So it does not include commercial buildings, but it does mean that if you have a mixed-use building, that the commercial section would need to comply with commercial code, and the residential section would need to comply with residential code. Existing buildings, additions need to conform with the full requirement of the new construction. So if you are building an addition, that addition itself needs to meet one of the performance pathways of the new construction code. The rest of the house that is not being altered does not need to be brought into compliance. Renovations and alterations have their own requirements that are defined in the existing code home section. Any project that is requiring an Act 250 permit will be required to meet the provisions of the stretch code and not just the base code. So something to be aware of as you're going through permitting. And stretch code has also been adopted by some jurisdictions in the state. Some municipalities have adopted stretch code as their standard versus base code. Exempt buildings, low energy use buildings, which is a pretty restrictive bar to be met. Unconditioned buildings, so anything that's not a residential building essentially. Mobile homes have their own requirements. That is a national standard, and those buildings will need to be met those requirements by the manufacturer. One note to make around mobile homes, though, is that any site-built components, so you're putting it on a basement, a full basement for some reason, or a crawl space, or some sort of foundation underneath, that would need to meet the requirements of the new construction code. Hunting camps, summer camps, basically seasonal buildings are exempt. Yurts, if you're into that, those are exempt also. And owner-built homes. And there's a distinction with owner-built homes. This has been used sometimes as kind of an out for builders to kind of, not have to fully comply with all of the requirements of the code. But the language around owner-built homes is pretty specific, and all of these conditions need to be met in order for it to be seen under the rule of the law as a true owner-built home. So there is that provision, and the owner is still required to submit an RB certificate, but there is a specific owner-built certificate that they're required to fill out that will define any deficiencies in compliance with the full code. And existing buildings, additions, alterations, repairs, must comply if changes of conditioned, unconditioned to conditioned space. So that's a trigger if you're taking a, I would use a cape as an example. If you have a cape with an unfinished second floor and you're doing a renovation project to turn that into conditioned space, that new conditioned space that's adding conditioned volume to the building is going to require that that area meet the requirements of the code for new construction. Insulation projects, if you are adding insulation to a building, the intent is to try to bring those areas up to the current code requirements, but it does allow for basically cavity fill, to fill the cavity that is exposed. So basically, if you're exposing an exterior wall and you have a rough sawn 2x4, that cavity needs to be filled with some type of insulation before it's closed back up. There's not a specific R value called out that's required. Replacement windows must comply. So if you're taking a full window unit out and replacing it, that window that you're putting in needs to meet the U value requirements of the new code. If you're just replacing glass, replacing the glazing in a window sash, that does not need to comply. Storm windows do not need to comply. So more distinctions in what is exempt and what is not for existing buildings. Liability, this is really, the way that the law was written. Since there is no code enforcement, there's no direct oversight by a state agency. The way that, there is some teeth to it is that a homeowner can take civil action against the person who's certifying the building, whether that's a builder or HRV or whomever. But the builder basically has the responsibility to be meeting the full requirements of the code. A homeowner can seek to recover damages that include energy costs, costs to bring the building into compliance, attorney's fees, etc. Claims must be filed under the full rule of filing it as a claim against RBES deficiency within 6 years. I'm sure if you talk to some attorneys, they'd probably see that there's more liability exposure beyond that 6-year window that would be relevant outside of the strict adherence to the RBES rule if there's building durability issues. One of the other factors that's coming into play here is we're seeing more adherence to RBES by way of the real estate market. More lenders and title attorneys are looking for the RBES certificate in order to close loans and mortgages. So just to be clear on this, though, the lack of that RBES certificate does not impinge the title of a property or a home, so the sale can go through as long as the parties agree that they're okay with that. Though, you know, there are some of these other factors mentioned here that if that certificate's missing, it may still become a factor in the sale of the property. So this slide here, as we start to go through the rest of these slides and discuss the application of the rule, you're gonna. I have the full actual reference points in the code itself, the full language of the code of what we're referring back to. So I'm not going to read through all of this, but basically R4013 defines what the certificate of compliance will be and needs to be. So basically, the person who has built the home or a entity who has been hired as a certified agent needs to fill out a code certificate, submit that code certificate to the town that the home was built in, as well as a copy to the Department of Public Service, and then a copy of that certificate needs to be posted in the house. The intent is typically to be putting it at the electrical panel, on the electrical panel or nearby, so that it's easily accessible. So, you know, that is the way that the code is meant to be implemented on a project-by-project basis. You may bring a code certificate to a town manager or town office, and they may look at it and say, what is this all about? Others may tell you, oh, that's where we file it right here in the town records, and here's the filing fee. So on a town-by-town basis, there's going to be some difference in their familiarity with filing of the code certificates, but that is the intention of how a project should be completed. Okay, now we're going to get into the general requirements of the code. So the full code language itself is arranged in 6 chapters, and this is what those chapters define. The way that the RBES was written was basically designed as a plan review type code. So the intention really has always been to use the code as a reference document at design stage to confirm that the building is going to be built with all of the applicable measures and component compliance. So the code is laid out in a way that helps move that process along. So Chapter 1, Scope and Administration, kind of goes through what we just went through in these early slides. Chapter 2, Definitions. So this is a chapter that I encourage everyone to get familiar with. It's basically just a glossary of terms, but it really, it does help kind of potentially clear some issues up that may arise in definitions and interpretations as you go through the code. Chapter 3, General Requirements. So this section kind of covers some of the design considerations and conditions that should be getting used for determining equipment and systems in the building. So building load conditions and building load design requirements, material systems and equipment. Big part of Chapter 3 is ventilation requirements, mechanical ventilation requirements, and combustion safety. The heart of the code and what the rest of these slides will cover today is in Chapter 4, residential energy efficiency. So this section basically covers all of the building component requirements, the R values, the U values, the alternatives, the installation specifications for those materials. So it's kind of the bulk of the code, and as the 2020 code is written, it's kind of built around the prescriptive compliance path. Chapter 5 is specific to the requirements for existing homes, and Chapter 6 is basically just a summary of reference standards being fuel codes, the IECC, the IRC, the IBS. I get IBS sometimes thinking about the code. That's something different though. So there's plenty of content there to refer back to. So prescriptive compliance for new construction and additions here. Again, if you're building an addition, it needs to meet these requirements as if you're building a new house. And again, the referenced sections here, sections R402 through R404. So just to review quickly, compliance methods, you have 3 options to comply with the code: the prescriptive tables, which is what we're going to cover, the ResCheck software method, and the HRV rating pathway. The ResCheck tool is still in the process of being updated to be in alignment with the 2020 RBES from where it was left before, which was in alignment with the 2011 RBES. So it's still kind of a clunker at the moment, but is being updated and should be ready at least by September 1st as an option. The HRV rating pathway is the option that Efficiency Vermont offers as far as enrollment in our new construction program. So if you enroll in our new construction program, we will provide the HRV rating services for you. So prescriptive packages, the reason I focus on the prescriptive approach, not only because it's kind of the backbone the rest of the code is built on, but I think many builders use the prescriptive packages as their method for compliance because it's pretty simple, pretty straightforward. You're not looking to do calculations. It typically tends to yield to accommodate most building types, although there are some limits in flexibility because you can't swap one performance value for another by way of prescriptive compliance. You have to follow the tables directly. But again, it's the backbone of what we're building the rest of the code on. So one point to make as a big difference from the 2015 to the 2020 is that in the 2015 code and in previous versions of RBES, there is this table of R40212 that was minimum performance requirements for the building. So this was basically like the baseline of like you had to build at least to this standard or better. And then there were the prescriptive tables, which were separate from this also. This table no longer exists. This minimum performance package no longer exists. And our reference point now are the for the prescriptive compliance, these 5 packages that are available for that method. The code review process has basically eliminated cavity-only installation for above-grade walls, except for one package. So there's only one package available now that you can just do cavity fill in above-grade walls. Code is moving obviously in the direction of continuous installation requirements. So there's 3 different continuous installation packages. Log homes are kind of their own, separate category. They have their own requirements, and there is a prescriptive table in the code specific to log homes. So as a reference point for the packages, I'll talk quickly through package 4, the cavity only. So any of the continuous installation options, your ceiling requirements are going to be fine. R49, if you're going to do cavity only, you're going to be required to get up to R60 in a flat attic, R49 in a slope. A bigger bump here is foundation insulation. Goes from R15 to R20 continuous if you're going to do cavity only. Or a combination of R13 and a cavity with R10 of continuous as well. Slab edge here is pretty consistent across the board. So this is for any exposed slab, whether it's a walkout basement or slab on grade, unheated slabs specifically here. So this does not apply to slabs that are below grade. So if you have a full basement and the slab's under, 6 feet underground, 7 feet underground, and it's unheated, these requirements don't need to be met. but either R15 at the perimeter, or as an alternative to that, you can do R10 at the perimeter and run R7.5 minimum under the entire slab itself as an alternative to just hitting R15 at the edge. If you have any type of heated slab, R15 is required both at the slab edge and under the slab. Window performance here is a little bit higher than the other continuous insulation packages. Skylights stay the same, and high efficiency lamps, your lighting requirements basically don't give you a 10% out for non-compliant lighting. You have to be 100% compliant with efficient lighting. So the next big jump from this is, in 2015 and other versions, you would just choose which package you wanted to follow and meet all of those requirements and follow the installation requirements, and you're good to go. But moving forward here now, you're also required to attain points based on the size of the house. So this is a requirement prescriptively and with some of the other pathways here too. So you need to be gaining points in a points table based on the size of the house. So building size is based on everything within the thermal envelope. So even if you have an unfinished basement or some storage type areas, those need to be included in the calculation for square footage. And multifamily size is based on the average dwelling size for the building. So there's a pretty expansive table in the code book, or the code now, of what your options are for attaining points based on different categorizations. So I'll use, you can see that there's things where you can upgrade the walls from, if you choose the cavity only package and you want to comply with the component values in that, but you can flex on the walls. You can gain a couple points there. You can gain a point by having a pre-drywall blower door test done on the building to verify that you've got a well-performing air barrier. You can install balanced ventilation as an alternative to exhaust only. And then there's specific performance requirements if you are going to be installing an HRV or an ERV that are laid out here, and we'll touch on that a little bit further along here. So you're gaining points by combining any items in these categories to meet what's required based on the size of the house. Stretch code is a more stringent requirement for RVs than base requirements. So again, stretch code comes into play if you have a project that has an Act 250 permit pulled for it. And then also some other towns, South Burlington, I believe Virginia's now too. Williston has having not adopted stretch code, has some more stringent requirements around building performance. So section R407 in the code goes into the more full detail around some of the other provisions in the stretch code requirements. Stretch code has its own table. So these are your 3 performance packages you can choose from if you need to meet stretch code. You'll see that there is no cavity only option for above grade walls in stretch code. It does push you in the direction needed to do balanced ventilation, and if you are doing stretch code and you're going to use balanced ventilation in the building versus exhaust only, you need to be specifying a HRV or an ERV that has an ECM motor to it and has an efficiency of at least 70% for an HRV or 65% for an ERV. So these are things, this is why, the code is kind of written as a design document so that these things can be understood, defined, and specified at the beginning of the project. Because I tell you right now that it's much harder to find an ECM motor HRV than just going and pulling one from the stock at Webb's or Granite Group. They were working with those suppliers and distributors to help them get to the point where they're going to have more code compliant options available. But these are things to be having conversations with your subs about to make sure that everyone's clear as to what's going to be putting in and what's getting put in meets the requirements of the code. Same points requirements with stretch code, but a little bit of a bump up in the number of points required based on the building size. So again, the same tables we're talking about here that can be referred to for those points. So stretch code compliance, all the base code requirements need to be met, as well as what's defined in section R407 that is specific to the stretch code. So you have only two options with stretch code to comply. You can use the prescriptive path as we're defining here, or you can have a HRV rating done. You cannot use res check as an option to comply with the stretch code. And I don't go into detail on the solar ready, but basically there are requirements in stretch code for both electric vehicle charging and for components to be put in place to allow for the integration of photovoltaics either at construction or at a later date. So there are some direct provisions in stretch code that call those things out specifically. So getting back to base code prescriptive compliance, I'll just put it out here at the beginning that there is an alternative to meeting the full R values of the prescriptive tables that has carried through from previous versions of the code. This is the U factor alternative. So there's a table specified in the code that will allow you to do an assembly value versus a component value to comply. So this means that you have to be doing some calculations to understand what your full U value assembly is going to be versus what you have in the cavity. So an assembly with a U factor equal to or less than that specified in the prescriptive tables for R value shall be permitted with points. Without points, so let me go back to this for just a second. If you're going to use this U factor alternative as a base method for going, avoiding some of the component requirements of the prescriptive tables, you still need to meet the same points requirements that you would if you're going the full prescriptive component route anyway. Alternatively, and this is where this gets muddy, so I apologize on behalf of the world of code, but there is another alternative now to this that you can use the U factor assembly values and use that table for compliance without meeting the points requirements that we just showed you. But in order to do that, the building needs to be tighter than it would be for base code. So you need to be a maximum of 2 ACH 50 versus 3. And you're required to put in a balanced ventilation system versus having the exhaust only ventilation option. With the performance requirements that we mentioned here and I showed you before. So, as a backup to this, I provided Chris with some reference documents that I've created that pull out some of this content from the code that is specific to different trades. So basically, cliff notes for code, and we'll have those available to reference so that you're not trying to think back through all of this and remember how this all applies. So that'll be available to everyone who's wants to take advantage of that. So just briefly here, the difference between the R value and U value. I'm not going to go into real detail on this, but the key takeaway is that you have to be, in this method of alternative, you have to be doing that full assembly calculation. And not just substituting U value for R value in a component. So as I say here, the bottom line is try to meet the prescriptive values completely in the full 6-package prescriptive table. And these are the U value alternatives. So some other notable exceptions, ceiling insulation, where R49 is required in the prescriptive table, R38 can be substituted over 100% of the ceiling area as long as it's installed in a way that it's at full uncompressed height out over the exterior walls. The same provision is allowed for substitution to R60. You can use R49 as an alternative to R60 as long as it's also fully uncompressed over the exterior walls. Closed cavity ceilings, if you have a section of the building where R49 is not practical given the constraints of the framing members being used, R30 can be accepted as an alternative, but there are restrictions here on area, so be limited to an area of 500 square feet or 20% of the total insulated area. And also needs to be full uncompressed height all the way out to the exterior wall. So this next section here is a specific section of the code where it gets into actual performance requirements for the installation of materials in the building. So this kind of covers air sealing details, some of the stuff that was just alluded to here as far as, you know, actual installation of insulation and how it needs to be installed within the building. As well as other equipment installation requirements. So the next slides I'm going to go through here is kind of a summary of not some, but not all of those building system requirements. So these are the sections to refer back to in the full code if you want to know all of the installation requirements. So unvented attic assemblies, this is a big one. So we're talking, you know, full cavity type fill assemblies. No interior vapor retarders can be used on the ceiling side of an unvented attic assembly. Where wood shakes or shingles are used, air space needs to be created at the roof underlayment above the sheathing. Any spray foam, not closed cell spray foam, so open cell spray foam, shall either be a class 2 vapor retarder or have a vapor retarder coating or covering that foam if it's going to be used in a closed cavity assembly. So unvented assemblies continued. You can do unvented assemblies with these three different pathways, essentially three different cavity options. Fully air impermeable or spray foam insulation only, air permeable in the cavity only, or a combination of air impermeable and air permeable. Basically, here's the picture version of that. So fully closed cell, air impermeable insulation, full cellulose, mineral wool, fiberglass in the cavity with a continuous insulation layer above, meeting the 50% equivalent R value approximately that we're seeing in the cavity to continuous. And then finally the flash and bat or flash and fill assembly where you're getting 50% or so of that R value in a closed cell or air impermeable insulation, and then filling the balance with a fiber insulation. Eave baffles are specifically called out in the installation requirements. So basically you need something at the eave if you're using an air permeable insulation in a rafter cavity or ceiling assembly to keep wind washing from occurring through the installation. Attic access hatches or doors or crawl space hatches or doors need to be insulated to an equivalent value of the area surrounding it, and also weather stripped. There is an exception for using more of a like pre-hung type entry door as an option if the space allows for it. Floors, if you're insulating a cantilevered floor or an exposed floor over a crawl space, the floor cavity insulation needs to be in direct contact with the decking above, so you can't have a gap. You can't put a R30 bat in a 2x10 cavity and have it just lying there against the bottom of the joist. It needs to be in direct contact with the subfloor. Basement walls, basically top of the wall to the bottom. You know, down 10 feet or to the slab, whichever is less. Slab on grade floors, as was defined earlier in the table, of that R15 or the R10 plus 7.5 requirement. So these are any slabs that are either on grade or 12 inches or below need to meet those performance requirements. Crawl space walls essentially need to be treated as a basement wall would, with the inclusion of a class 1 vapor barrier on any exposed soils that would be in that crawl space if a slab has not been poured. Frame walls, above grade walls, there's more content in the code around vapor retarders and moisture control in building assemblies. The handbook, actually, a lot of great content in the handbook for this version that supports more of these options, a lot of construction details, assembly drawings that kind of show what some of those options may be. But basically, we're, more definition around not creating the vapor barrier sandwich. I think we're all familiar with, and the threat that that poses. So Class 3 vapor retarders can be used on the interior side of frame walls over certain assemblies. So vented cladding, meaning if you have a rain screen type assembly on the exterior wall, you can use a Class 3 vapor retarder on the interior versus a Class 1 or 2. And also on some provisions where you're running continuous insulation on the outboard side of the wall sheathing. If you're doing continuous insulation on the outside of a building over the sheathing, it is pretty important to be able to have a drying mechanism to the inside, and that's where this provision allows for that. Here's a table of some of the vapor retarder classes and material examples of different types of class vapor retarders. These are some of the examples of some of the references that are in the handbook. So some assembly types and descriptions of what some of those options are. Again, so I'm not going to go into these with detail right now because of the time, but this will be available for you to reference as you're looking through this content after we're done here today. And here's some wall assemblies not to do that kind of define that vapor barrier sandwich sort of assembly. Windows and glazing. Couple key points to call out here. Area weighted average of fenestration shall be permitted to satisfy the U factor requirement. So, if you're using the cavity only package and you need to hit a 0.28 U value for the windows, you can have, some windows that are a 0.28, some that are a 0.27, some that are a 0.29. As long as it all kind of balances out to be 0.28 or less, you're good to go. Up to 15 square feet of fenestration can be exempt from those requirements. Same thing, up to 24 square feet of exterior door assemblies are exempt from the U factor requirements. And that covers that. Air leakage is a full table in the code that covers air sealing details, requirements, specifications. So that is this table R402-411. So this goes into more specific detail around what areas of the building need to be air sealed and with what methods. In the full code language, it's all words. In the handbook, it's a lot of pictures. So choose your poison on that one to define which way to go for compliance. The key point here is that this table details the requirements for alignment of the air barrier with the insulation measures. So, I think we all understand at this point that your air barrier and insulation details and thermal barrier need to be aligned. And these sections go through that in some more detail as to calling out specifically areas that need to be addressed. But the continuity here is the big key. The air barrier needs to be a continuous, durable layer in the building. All joints should be sealed. It needs to be some sort of assembly that will withstand the test of time. And I encourage you to use some of the resources in the handbook to help guide any questions or communications with your subs on this. One of the key takeaways, I think, for anyone, trying to direct these outcomes on a project is there really should be somebody on the crew, whether that's a lead carpenter, whether it's the GC himself or herself, or an understanding with your subs that, this is an integral part of the performance of this building. And attention needs to be paid throughout the construction process, that details are not missed or changed or altered throughout the construction process So someone, I think, on the crew or within the process needs to be accountable for the outcomes of the installation of the air barrier and integrity of the air barrier. So I'm not going to read through all of these, but these are some of the things I pulled out that are specifically called out in that table as requirements for attention. So some examples of, both an exterior air barrier assembly and an interior air barrier assembly, and the continuity that's required and where those key transition points and connections need to be attended to. Also in the handbook, there is a full checklist of air sealing details and this drawing that references those items in the checklist. So we'll take a second to talk about, now that you've put all this hard work and effort into attaining a tight building envelope, what do we do to verify it? For new construction, you are required to contract with or hire someone who has the background and experience to be able to properly do a blower door test on the building and report the outcomes. A BPI certified professional can be hired for this. A HRV rater, a verified resident HRV rater can be hired for this. A HRV field inspector, and the Department of Public Service, in conjunction with Efficiency Vermont, we've also been working on providing basically a testing certificate for builders or for others who want to get trained on properly using a blower door and being able to perform these tests for new construction and additions. So it is a requirement that testing be done and that the outcomes of that testing be reported as a part of the permitting or the RBES process. A few other items that I'm calling out here specifically to be aware of is any wood burning fireplaces or stoves in a new house or addition shall have tight fitting and gasketed doors, as well as outdoor combustion air directly to the firebox. And this requires, if you're building using a factory-built assembly, that it is actually UL listed and labeled to meet those requirements. And if you're using doors on a masonry fireplace, it also needs to be a UL listed assembly. So full details on this are available in Chapter 3 in the combustion combustion safety section, but definitely something to be aware of. And I mean, I'm not going into the detail here, but this mentions how any home being built right now to the 2020 RBES is basically going to be considered of unusually tight construction as defined by the fuel laws or fuel requirements for combustion equipment. So basically any combustion equipment in a new house needs to have combustion air supplied directly to the burner or the firebox, closed combustion equipment only. So that is specifically called out, and definitely something that we all need to be paying attention to, because last thing you want is a beautiful stone fireplace in a brand new house that doesn't have enough air to burn the wood. So section R403 is getting into mechanical requirements. I do have another training, talked with Chris about, that we could potentially offer here in the coming weeks too, that gets into more of these details about what the mechanical requirements are for new construction. Or in the code in general. There's a lot of stuff here that really needs to be paid attention to, and conversations that need to be had with our mechanical contractors to make sure that we're getting performance and outcomes that align. Big part of this is actually doing load calculations and distribution design for mechanical, for both heating, cooling, and ventilation equipment. So there's specific language in the code in both Chapter 4 and Chapter 3 that detail those requirements, and then I certainly encourage everyone to become familiar at least with what those requirements are, so you can have informed conversations with your subs. Electrical and lighting systems. No less than 90% of the lamps in a building or bulbs need to be LED or CFL or high efficiency fluorescence, which is pretty easy now because that's pretty much what's available on the market. Electric resistance heating is specifically called out at this point in the code because of some circumstances that are arising around equipment options. So heating a building with electric resistance only is prohibited. If you're using heat pumps, they need to be cold climate rated heat pumps that if they do have any supplementary electric resistance heat, they should have control so that that supplementary heat does not come on when the heat pump itself, the compressor, can meet the full load of the house. In more specific detail, this calls out that a replacement of existing electric resistance units is still allowed. So if you have an existing home and your failed electric resistance strips or otherwise, those can be replaced with new without being non-compliant. Electric resistance heat can still be used in limited areas of a house where the distribution of the main heating system cannot reach those spaces. So this is kind of aligned with what we're seeing with, new buildings being built that are highly efficient and utilizing heat pump equipment, either compact ducted, centrally ducted, mini splits, air to water, where the code will allow for a resistance panel in a bathroom that's not being hit or met by the central distribution system. So along with that, any buildings that are using heat pumps as the primary heating system, electric heat can be used as mentioned, but that supplemental electric resistance needs to have some measure of control on it that'll prevent it from operating when the outside air temperature is 5 degrees or higher, basically meaning that the heat pump in those conditions can meet the full heat load of the house at a COP of 2 or better, which is what the cold climate heat pump rating would require. And also, in order to use electric resistance as a backup in these situations, the building needs to be 2 ACH or better. And then multifamily buildings have some other exceptions around performance that will allow for electric resistance to be used. So electric vehicle charging, this is something where this is triggered by multifamily as well as stretch code. So multifamily developments of 10 units or more shall provide level 1 or level 2 electrical chargers based on a percentage of units built. So that same requirement needs to be met if you're in a jurisdiction that has adopted stretch code, or again, if it's an Act 250 permitted project, you'll need to provide electrical vehicle charging stations, at least one in that circumstance. Last few slides here, we're going to go into mechanical ventilation requirements. This is detailed in Chapter 3 and also some sections in Chapter 4. I'll just say as a public service announcement, mechanical ventilation is a huge thing that we all need to be paying attention to now because we're getting much tighter building envelopes by default just because of the building materials and construction process going into residential building at this point. We need to be able to manage moisture, especially in these buildings, as well as just general indoor air quality, especially given our current circumstances. There's a lot more attention being paid to indoor air quality. So it's something that we all need to make sure is getting done and done as best as possible and as best as can be afforded in any building. So every new home needs to have a whole house ventilation system as defined in the Chapter 2 definitions, as I mentioned earlier, worth referencing. So that whole house ventilation system can be either exhaust only or balanced ventilation. So in order to comply with those requirements for a whole house ventilation, you can either use a prescriptive table that's available in the code, R3046, or you can actually do what I think we all should be doing, which is figuring out what the ventilation requirements are for the house specific to the house by using one of these defined standards for calculating building ventilation rates. The most common and the industry standard is the ASHRAE 62.2. An alternative to that is the Building Science Corp standard or passive house ventilation calculation standards. So you can do prescriptively by following the tables, and we'll show you that here in a second next, or do the actual calculations. There's some easy tools online that can help you do those calculations. So prescriptively, you can, given the number of bedrooms in the house, you can install in a 3-bedroom house one bath fan, essentially rated at 100 CFM, and call it good. You've met the whole house ventilation requirements as long as that fan is run automatically. I'll leave it up to you to decide that if you have a 3,000 square foot house or a 2,500 square foot house with 3 bedrooms in it, and you have one bath fan as your whole house ventilation system, whether or not that's going to function as a whole house ventilation system. So that's just my little public service announcement on that one too. But you can do that, and you can meet the code prescriptively and good to go. So, or alternatively, like I said, you can do the full calculations and look at a more distributed ventilation system. While meeting the whole house ventilation requirements, bathrooms that have bathtub showers or spas or a similar fixture have specific performance requirements that need to be met too. So there's a minimum ventilation rate that needs to be met in those rooms outside of what the whole house ventilation requirements are. And that essentially is this performance requirement here. So bathrooms need at least 50 CFM of intermittent exhaust if it's going to be just on or off controlled switched, or 20 CFM if that bathroom exhaust is being met by a whole house ventilation system. So basically, like the 50 CFM is if you have an independent bath fan in the bathroom itself serving the bathroom. The 20 CFM requirement is basically if you have an HRV, ERV, or some other sort of centrally ducted ventilation system that's running continuously. It needs to move at least that amount of CFM. So HRV and ERV details, base code, HRV and ERVs are not required for compliance with the package, prescriptive package approach. The HRV or ERV is required if you're going to use that U-factor alternative that I mumbled through earlier, or if you're going to go through the res check path. If you're going to use one of those two alternatives to prescriptive compliance, you need to be putting in an HRV or an ERV. And again, if it's a stretch code compliant project, ERV or HRV is required. So if you are going to be putting one in, it has to have that ECM fan motor, and that has to be, you have to be looking for that specifically because many models do not have ECM motors in them. And these are the minimum performance requirements for heat recovery for HRV or ERV. I'm definitely not going to read all of this, but basically this details there are requirements for controlling those systems. So essentially the bottom line is the whole house mechanical ventilation system needs to operate independently of the user or the homeowner. It needs to be set up in a way that it can run on its own without a homeowner turning it on or off or wanting them to turn it on or off. Part of the mechanical requirements training that I've put together kind of goes into more detail about distribution design and best practice for both forced air systems and ventilation, because a big key in a lot of ventilation systems for them to do what they're designed to do and protect you as the builder so you're not getting callbacks, you know, because of moisture problems and other things, is that you want to make sure that ensure that that homeowner is using the ventilation system. And if you put in equipment that's noisy, either the actual HRV or ERV itself does not have a very good noise rating, or if you do a lousy job with the ductwork and the ductwork's noisy, homeowner's probably going to turn that ventilation system off. And then, you know, whatever's been invested in it is lost. So it is important to understand the implications of equipment choice and distribution design. And last slide here, clothes dryers need to be exhausted directly to the outside of the building, except if it's a heat pump or condensing dryer. Obviously, there's no venting on those. And one last key point here is range hoods. If you have a client that's insisting on having a commercial range hood in their kitchen because of the aesthetics, and that range hood is rated to move a couple thousand CFM, you're basically going to deflate the balloon of that house when you turn that on, and it could wreak havoc on other systems in the house by way of depressurization. So the code specifically calls out that if you have a range hood that's capable of exhausting 400 CFM or greater, that some sort of makeup air system is put in place to turn on automatically when the range hood is turned on, to either passively bring in makeup air or actively bring in makeup air by way of an inline fan. And in doing that, you, in our climate, need to be considering some sort of tempering to that air probably too. So, you know, where and whenever possible, try to limit the flow rate of any range hood to 400 CFM or less. But if you are going to be going beyond, this is a requirement that is triggered. So that was the shotgun fire hose approach to getting through the prescriptive compliance path for RBES for 2020. I'll share more content through Chris that'll be available for you for reference, and hopefully, you know, be able to do more of this type of content down the road with you. The Energy Code Assistance Center, feel free to reach out to that number at any time, and you'll be able to get questions answered. Also, the Department of Public Service can be reached for questions on the application and implementation of the code. And also feel free to reach out to me directly. So thank you very much.
Great. Thank you, Steve, for coming and giving us all that introduction to the prescriptive pathways that are in the new code. If we have a couple of minutes, please feel free to go. The video of this will be posted on the Homebuilders website. That's homebuildersvt.com. I did also, under the Education tab, I also did upload the supporting documents that Steve sent me this morning. Thank you, Steve, for that. And so you can download all of those. And we will be having more of these. If you have questions specific to what Steve went over, I believe that Steve is giving you his phone number and his email there, so you can contact him directly. And as
I'll
soon
stay
as
on the line here for a bit too. If anyone
great, yeah, we'll
wants to bring up
do
any
some questions. But I wanted to make sure that everyone who needs to go has the opportunity to. If there are any questions, I'm just looking at the chat. If you could throw them into the chat, that would be great. That way I can read them. Of course, the biggest change here to the entire code is that whole points thing, where you have the prescriptive pathway. You choose one of the 5 pathways. Then you have an opportunity to fill in depending on the square footage. That was done specifically to make sure that the larger the house, the more energy efficient bits you're required to put into it. So it's specifically geared towards that. Are there any questions here in the chat that people have that they'd like? Here we have John. Does the R15 requirement apply to any heated slab, or only to any heated slab that is not below grade?
Any heated slab. So it specifically calls out if it doesn't matter where it is in alignment to grade, it does need to be insulated to those requirements.
Great, thank you. Any other questions? It is quite a bit to digest. Is electric radiant heat considered electric resistance heat?
Yeah, that's considered an electric resistance mat type situation. So if you're talking about using something like that, embedded in the tile bathroom floor, and it's a supplemental to the whole house system, given the parameters that I laid out earlier in the code here, it could be allowed under those circumstances.
Great.
And I think I see Dennis had mentioned earlier on about the Energy Star version 6 window criteria as an alternative to the U-value requirements. So that's also true. Yes, that is an option still, that the Energy Star calls out specific solar heat gain coefficients paired to U values as a criteria for meeting equivalency. So that is something that is still an option in the 2020 code.
So John asks, do the new diagrams address products such as zip R-board, or only rigid foam / mineral wool apply to the exterior sheathing?
No, the construction details do in the handbook and in the session I included here have some zip R or nail-based panel assemblies shown. Actually, the prescriptive tables one of those prescriptive tables was actually designed around the nail-based panels. So that's why it's an R5 or an R6 continuous insulation plus cavity. The reason being with that is that there is some risk mitigation in having the sheathing outboard of the foam with a nail-based panel versus the sheathing behind the foam. That's why if you look at the construction details here specifically to the nail-based panels, it calls out using a vapor variable interior vapor control membrane. So like an Intello product or the CertainTeed membrane or craft facing, something that's going to prevent moisture drive during the heating season, but will open up and allow for some moisture transfer and drying potential to the inside of the building under certain circumstances too. So it's, and that's what's, this is stuff that we all should be paying attention to now, regardless of our interpretation or adherence to code, because this is the reality of the materials that are going into buildings now and the dynamics that we need to be paying attention to. So we tried to put as much of that content and detail as possible into the handbook for reference. There's many more resources out there now than there were before as far as, best practice for putting these assemblies together.
And an important point to bring up is that although the data sheet will say that the green coating on the outside of zip is vapor open, zip itself is basically just OSB. So you cannot consider that to be a vapor open assembly. There was a question from Mar, do we think there are enough blower door testers available in Vermont?
There are a significant number of BPI certified individuals working in the state. Many of them work in our home performance with Energy Star program. So those are all verified, certified individuals that under the rule of RBES can do that testing and do that verification for a builder. We, as I mentioned also, that there is, I think there's a question here from Jay, will builders be able to perform there? And I'm assuming blower door tests.
Blower door test, I'd imagine.
Yeah. So it was probably a year ago anyway, there was some blower door trainings that we were done that was coordinated with the Department of Public Service to train builders to do the blower door testing themselves, and basically you get a certificate of knowledge, or that you know what to do as a result of that. The plan is, this process has kind of dragged itself along quite a bit with the department to get it to where it's at now. So the department, I think at this point, is just trying to get everything in place for the code to, be enforced as of September 1st. I expect shortly thereafter that there'll be more communication and plans to do more of those contractor, builder type lower door trainings, so that if in that situation is something that a builder wants to attain for themselves, that would be accommodated.
John also asks, is there any certifiable database of vapor permeable ratings for permeability ratings, or should we still continue to refer to manufacturer data sheets and compare?
I would suggest getting after Green Building Advisor, using Green Building Advisor as a resource because of independent, if you want to call it that, testing that they've done. And, there's a lot of good resources through Green Building Advisor. Building Science Corp also has done a lot of testing of actual performance versus, what's stated out there. Chris, what you just mentioned is a great example. The ZIP product line, was developed around code compliance. These products don't come out of the blue. They come out of a need for meeting certain performance specifications. But to have a coating on a piece of OSB that the coating has a perm rating of 20, but the OSB behind it has a perm rating of 3, that 20 perm rating of the coating is pretty much irrelevant when you're basically blocking the moisture transfer by the material itself. So it is important to get as best of an understanding as possible of the different characteristics of the building, of the materials going into an assembly. So those are my 2 suggestions: Green Building Advisor and Building Science Corp as ways to dig into some more of the testing that's been done out there independently.
Scott Mathers has asked about, wouldn't it be great if DPS or the state would put some teeth in the code? Well, I will jump in on that because I'm a member of the advisory board that went over the code, and we did ask for teeth. There's no political will in the State House to put teeth in this any more than they have. The fact that they finally went to a required blower door test to test instead of visual inspection for 3 air changes per hour was seen as a huge victory. So we're with you there, Scott. There's a definite faction within the advisory committee to make it more enforceable instead of just a poor duped homeowner having to take someone to court in order to get these things fixed. However, there's just not the political will right now in the state. We'll see. We're hoping that since we have been able to get the blower door test passed and into the code, that will give us the ability to over time tighten the air tightness from 3 air changes per hour, ultimately down to 1 air change per hour, in which case every house would be needing mechanical ventilation. Hopefully that will be something that we'll be able to get in the next code change, or moving in that direction in the next code change. Will builders be able to perform their own blower door tests? That was also just asked. Are there any more trainings scheduled on? I just want to make sure, Jay, that you did get that answer. The answer is, I believe that the code allows for, it does not require third party.
It does.
It does.
Well, it requires a certified individual, and actually, that is a good question.
Yeah, my understanding, we tried to get it third party, but I believe that it is not required that a third party do it. It's just good practice, because if you're getting certified to certify your own building, and you're certifying your own building, although that may be good to the letter of the law, it does not embody the spirit of the law, which is to have somebody else look at your building and say you're meeting the code requirement. I'm hoping, once again, even though I believe in this version, and maybe Steve can speak to this, that the third party is not required. It is recommended, and hopefully in the next version we'll be able to get third party certification required. When we were looking at this, we did find more than 100 blower door certified, either BPI, ResNet, or Efficiency Vermont trained blower door technicians in the state. So we certainly, I believe, have who's against it? Yeah, good question, Russell. Who's against making the code have more teeth? I'm not going to point fingers, but we all have understand that when you're at a table with a number of stakeholders, that some stakeholders see these as threats to their business, and I'll leave it at that. Okay.
And And I'll just
Yes.
mention, Chris,
Go ahead.
in the full language, it is just saying that it needs to be tested and verified by one of the different certified groups, by their BPI, HERS rater. It does not specifically call out third party as a requirement there.
I think I remember that discussion and that it didn't fly. Is there any requirement from John in the new RBES for the method of ducting an HRV into the home, i.e. standalone or integrated into the HVAC ductwork?
Okay. And maybe the same, John, but I see your mention above earlier about the full code language being posted and the draft version of the handbook available yet. The draft language of the code is up on the department's website under the energy code update, specific in the energy efficiency section. The handbook is not available through the website or through the department yet, and it should be available in at least a digital copy of it in the next couple of weeks here, and then it'll go to a printer, and we'll work on distribution, and I'll work with Chris and VBRA on distribution of that. So handbook not accessible at this point, a digital copy very soon. Full code language, draft adopted language is available on the department site. HRV ducting, no, there is no requirement to do either a standalone duct system for balanced ventilation or integrated into the HVAC. There are definitely design considerations and installation considerations when doing one or the other. I'll just say on a note of experience in testing many of these systems over the years and being involved with them, you get a hell of a lot better chance of getting what you want for actual distribution with a standalone system than trying to integrate it with the HVAC ductwork. You know, HRVs, ERVs are designed for a specific flow rate under a specific static pressure that is drastically different than what the design parameters are for a forced hot air heating and cooling system. So the two don't blend well together as far as delivered CFM, and you're often paying an energy penalty in that situation too when you combine the two, because when you start moving the ventilation air through the HVAC ductwork, you're kind of really needing to rely on the air handler, the motor of the HVAC system, to move that distribution air. And oftentimes that's not going to be as efficient of a motor, and it's often also a much larger motor than what would be coming from the HRV. So I would just say, you know, you can do it both ways. And I believe in one of the documents I provided, Chris, the supporting documents, there is a best practice installation document for balanced ventilation, and it shows different methods for standalone and integrated. So it's just something to be digging into a little bit more, thinking about.
I would agree completely. As a building energy consultant, integrated systems are really hard to get the fresh air right, because you're talking an entire whole house ventilation system for a 2,000 square foot house. For ventilation is 90 CFM, maybe 120 CFM topping out. And if you're using forced hot air to heat your house, you're talking hundreds and hundreds of CFM. And on and off, and those two things often don't work well. I agree, Steve. Okay, that unless there are any more questions, I see that we've come to the end of that. Steve, once again, thank you so much for all of your help and your willingness to come. And once again, to the assembled crowds, if you have a specific question that you would like to have covered in a presentation like this from either VEIC or someone else, please let us know, and we will try to do our best to make that happen.
There's one more, Chris, sorry to interrupt, but one more mention from Ryan, if there's any more training scheduled, online trainings. So the full 2.5 hour RBES training that I did yesterday, we'll be doing that again on August 5th, I believe it is. That's posted on our website, and I'll get that link to Chris also.
That link is already on our website. If you go to the education
great.
page, it says click here for a list of the trainings, and that includes all of the RBES trainings that they're going
Great.
to have.
And I hope to do more with VBRA also, on kind of expanding upon this topic. So, I mean, this is just one kind of condensed way of getting this information out there. I put a lot of effort into, as I said, and with the documents I provided to Chris, a way of kind of distilling the key points of the code for the actual end users, kind of siloing out what, if you're a general contractor builder, what you should really be aware of and be focusing on, and getting you that relevant information as tight as possible. And then the same with an HVAC mechanical contractor, pulling out the provisions of the code that really kind of apply to their day-to-day work, making sure that they have those resources available. And then also with designers, architects, their pathway too. So I've structured more trainings around this. I've been trying to, put this information out there over the past 5 years in a way that I think can communicate well to builders, because, I have experience in implementing this as a builder myself, and trying to, get the information out in a way that's relatable to your day-to-day work. So if you have any ideas on content or things you'd like to get more specific into, please reach out to Chris and or me directly, and certainly happy to accommodate.
Great. Okay, well, thank you everyone, and thank you again, Steve. I will be compiling and downloading the video for this, so if you want to look back for any reason, by later this week we'll have that video on the education page of the Home Builders website, which again is homebuildersvt.com. And thank you very much, and have a good rest of your workday.
Okay, take care all. Thank you.
Bye.